Hello, good evening. Today I will be talking about attention, the attention module in specific in Transformers. All right, this presentation I will try to explain to the best of my ability and as simple as possible about how what's going on inside the attention module. All right. So the big picture of the Transformers, right, is that the primary goal of a transformer is to predict the next word in a sequence. First, the input is broken down into smaller units called tokens. These can be actual words, these can be parts of words, punctuations. Uh, the point is that they are small chunks of text in this case. Then these tokens are converted into embeddings. We can think of embedding as kind of like vectors with many dimensions, high dimensional vectors that capture the meanings of the words. The job of the transformers is to adjust these embeddings and providing the context, what these words actually mean based on the context. For example, I have this little example that I made. Let's say we input "Hello, how was your?" and then we ask the transformer to come up with the next word. It'll give us kind of a distribution of probabilities of the next word. Right? It does all of this internally, but for example, it'll say that day is 70% likely to come next, evening 20, hello 4%, dog 3%, and game 3%. Like I said, I made this up. I don't know. And since day is 70% likely, then it'll choose that day and it'll fill it in. Or like I said, the biddings are adjusted based on the context of the text, right? Um, this is because words have multiple meanings. For example, the word bat. On one hand, we can say that baseball players use a bat to hit the ball, and on the other hand, we can say that the animal that sleeps upside down is called a bat. So the initial beddings lack context. This is where attention comes in. It allows the embeddings to share information between themselves, refining the meanings of the words based on their surroundings. The attention mechanisms enable the model to move information between embeddings even if they are far apart in the text. Okay, so the attention block uses queries, keys, and values to let words know how they relate to each other and pass information within a text. The query determines what is relevant. The key answers the queries, and the value is the information that is passed along. So queries essentially ask what's relevant to me. For example, in the picture up top there, if we focus on the word creature, the word creature is going to ask, is there any adjectives? Is there any nouns around me? What can these words around me tell me about what I actually mean? The query vector is obtained by multiplying the embedding by the query matrix. The keys. Each word is associated with the key vector. The key vector answers the queries. The key matrix, like the query matrix, maps the embedding vectors to a smaller dimensional space. Lastly, each word has a value, which is the actual information that gets shared between the words. The value is created by multiplying the embedding by a value matrix. The value matrix determines what information should be shared. Now we have attention pattern. To figure out how important each word is to the others, we take the dot product of the queries and keys. Then we use something called softmax to turn these dot products into an attention pattern. The attention pattern is like a heat map, showing how much each word is paying attention to each others. How does it work? So the model calculates the dot product between each query and each key. So what's the point of the dot product? Basically, the dot product helps the model figure out how much each word should pay attention to every other word in the sentence. It's kind of like figuring out which words are relevant to each other. Let's say each word has a query asking what's important. So, what does the answer to the dot product mean? So, if in the dot product we get a big positive number, it means the key and the query are a great match. That means that they are related to each other. For example, in the phrase fluffy dog, fluffy would have a large dot product with dog. If the answer here is small or negative, it means that the words aren't really related to each other. They don't have much to say to each other or about each other. Now, with these scores, we're going to get some numbers that are a little hard to work with. So, in order for us to get some easier numbers, we use something called the softmax function. This essentially turns the scores into probabilities, numbers between 0 and 1 that add up to 100% between all of them for each word. This creates the attention pattern, showing exactly how much each word influences the other. Let's talk about multi-headed attention. Instead of looking at a sentence just one way, the model looks at it from multiple angles at the same time. There are models like GPT-3 that use 96 attention heads per layer, each focusing on a different word relationship. Each head has its own key, query, and value matrices that help them understand different parts of the meaning. And then the model just combines all these perspectives to create a better and more accurate word representation. And then there's masking. During training, we don't want any future words to influence the current ones. So to prevent this, the model sets those future word values really low. This is so that when softmax is applied, they basically turn into zeros. This kind of keeps the model from cheating and ensures that it processes the words in the right order. Because this can be ran in parallel, this block is also scalable. This means that we can build bigger and better models. Basically, this attention block is, for lack of a better word, the magic that lets these models understand what we are saying and respond in a meaningful way.